లేకపోతే దాంట్లో మైక్ ఆన్ చేయమంటావా?
వద్దు, ఇందులో ఉండని.
ఒక్క మైక్ ఆన్ చేస్తున్నా
అందులో చేస్తావు.
అందులో చేయమంటే అందులో చేస్తా.
అందులోనే ఇది బెటర్ అనుకుంటా. ఒకసారి నువ్వు ఆన్ చేయు, లైవ్లో చూడు, సౌండ్ వస్తుంది కదా, అందులో మాట్లాడతారు.
ఇక్కడ చూసి
Hello. Okay. Hello. 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 Indeed.
బయట పెట్టాలి. వాళ్ళు తిరుగుతూ ఉంటారు కదా, వాటిని పెట్టేసారు.
Hello guys, I welcome all of you to Local Academy Day 3. Today we're gonna learn how to build LLMs from scratch. Of course, we're gonna look into the architecture of LLM, how we're gonna build it. We're gonna code it. Also, probably not exactly code it. I'll give you an explain how the code runs. I'll give you the what is the code. You have to copy paste and run it. But then the intelligence behind the code will be explained by me. Understand? You have to run over it. Yeah. So I'm Sugun. Shiva, we will take the session today for today, which is building LLM from scratch. Before starting off with the session, I would like to tell a small story about where all of this started. Well, AI existed since 1953. Then, why did it become part of our sudden revolution? Oh. Do you know the research method called attention is origin? How many of you know about the research method? No. Then this is an exciting story for all of you. So, what seven of the total is the knowledge? researchers inside Google, 7 members of them, they sat down, they drafted a paper which explains the architecture of today's modern LLMs, which is basically a transformer. Before that, most of the LLMs used to predict the next token only, using the previous token. But then, when transformer architecture came into the picture, now a single word checks the probability of each and every word that can be predicted next. And on top of that, every time an LLM generation output, it's going to be unique. All of this is something that was designed into the transformer that who beat that Google Pay. This became the base of every GPT model that you are seeing in the market today. Of course, things were made here and there. Fine tuning was done. Data was loaded. Large amounts of data was loaded into the LLM. You see Gemini, GPT, all of this stuff. Right? Each and every one of it is trained in a different way. It has a different amount of data loaded in it. Be it local LLMs or once you use using APIs. Each and every LLM is unique in its own way. Right? So, in today's session, what we are going to build is that we are going to build something called a character level LLM. Instead of taking one whole word and predicting the next word, what we are going to do is that we are going to take a single character and we are going to train it in order to predict what next character might be. It doesn't predict all of this stuff. So whenever LLM tries to predict the next letter, what it does is that it takes the probability of all the letters that it can predict, and from which it takes a maximum probability. But then it is not guaranteed that the maximum probability letter is predicted. We'll look into that at the later part of the session. But moving on, we'll look into the basic architecture of LLM. So what exactly happens in an LLM? What is it? Whenever an LLM is built, you basically train it on a large amount of data. But then since we have very limited resources, what we are going to do is that we are going to take a very small data set, which is around 1 MB of size. I will be sharing it to you soon. It is basically a compilation of all the Shakespeare dramas, okay? All of the important context or important paragraphs related to the Shakespeare plays. It is around 1 MB size. I'll send it to you soon once I start coding. But then it is a very small data set with limited number of characters, which we will be using in order to train our LLMs. So what do? We need large amounts of data for that particular model, and what does it exactly do? It doesn't it does not remember anything. Instead, it learns patterns, right? So the different patterns, what are they? Be it grammatical patterns or punctuations or what word comes in. I'll give a small example. Say this is a cat. It is sleeping on the couch. Now, when I say this to you, when I say the second part of the sentence and I say sleep, where did you reference it back to? The cat, right? These are all patterns that the LLM will do. These grammatical patterns, or if I say convert this from indirect speech to direct speech, what do you do? When it was a double equals. So all of these patterns are something LLM will do. It will not, it will not output any of it into itself and learn. You say Vartaman, right? It will not do that. It will learn. That is what an LLM will do. So once you feed the data to a GPT, it will learn all of those patterns, and once you give it some particular context, based on that context, it is going to predict what might be the output. Now, let's look into the architecture of the LLM. As you can see on the screen, we have a very small diagram. This is a very basic architecture of LLM that we will be building today. You can add a lot of elements to this, and you can enhance this particular architecture over here and build a better GPT. But then these are the parts that we will be focusing on as far as today's concerned. So I tell you about input, right? So we can take large amounts of data in order to train an LLM, but since we have some resources for directly speaking with a very small data. Next is the part tokenization. We will look into that once we talk about what tokenization is, what embeddings are, and all of that. The next part of the session is of course embedding and stuff. And then moving on, we will be looking into transformer inputs. So transformer, the transformer that we are building today will contain two main parts: the self-redemption part and the feed forward. Self-redemption is where the model will look at the word and it will think, okay, what words can what is the next word? It will set the probability system. Feed forward is somewhere all of the data, all of the probabilities that we calculate will get fine. Then, how many of you have idea of the real results in a data? Okay, it's okay. I'll tell you what exactly neural networks are. So, in case this AI was a combination of MIT and whatever this is. So, how do you approach AI? First, you have to understand machine learning. Right? Once you are very confident about the algorithms and machine learning, whatever the algorithms, you go move on to deep learning. Deep learning is really exposed to neural networks and how all of this stuff. A combination of ML and EL gives you humanized AI, which you see in markets right now, like Gemini or ChatGPT or anything. Whenever an LLM talks to you, doesn't it feel like it's a human over in the background who is sitting and everything. Kind of weird. But it kind of learn how humans talk, how humans talk with each other, and it's generating the output. So as you can see, this is a very small diagram of neural networks. So basically, you provide an input, and all of those orange balls or blue ones or green ones are different layers. Okay, this the first one is a single layer, the second one is another layer, the third one is a different layer. So whenever you provide an input to an element, it doesn't go through one single pass and doesn't give you an output. What it does is that it takes your input, it refines it like 1,000 times, and it understands what that context is before actually generating an output. So, what I want to tell you simply is that neural network consists of many layers where your input is refined as much as possible before generating the output. This is what a neural network is. Each and every layer has its own importance and stuff. We'll look into that at a later point. So yeah, these are neural networks. So what we are going to do in feedforward is that when we are moving from one layer to the other, we are going to refine our data. We'll look into that. We'll look into how we are going to do that when we learn about feedforward and feedforward network. So comparing the feedforward network and the self-attention, we are going to get one single transfer of power, which will help us generate the output. Okay. After the output is generated, see, we are going to do two things. We are going to train the LLM. We are going to make it generate an output. Okay. As part of the training, what we are going to do is we are going to estimate the loss in each and every iteration that we go through, we take the input. Right? So what we are going to do is we are going to take the input, and we are going to run it as many times as possible so that you can refine. Now, how do you refine the element? You have to do something in order to refine the element, right? So what are we going to do? We are going to calculate the loss. So basically, what loss is like? How is my generating context and my output context related to each other? We are going to take that. We are going to estimate how much loss of data happened, and we are going to reduce the loss so that we get a better output at the end during this. Okay. So after calculating the loss, we will optimize our model. We look into that also when we deal with that one. But this is the basic architecture of LLM that we will be building today. In case you have any doubts, you can just clarify. Moving on. Right. That is basically the normal GPTs that you find online. It contains, since I told you that we are going to build a character level LLM, everything we do will be somewhere, let it be at the character level. It will not be somewhere in the tokenization, like series of characters. When we tokenization is the next topic, I'll explain AI very clearly. But then, as far as now, let me tell you that we are not going to use string of characters at once. We are going to use single characters and we are going to predict what the next thing. Okay. Before I start up this organization, I would like to clarify some of the common Python like functions or things that are present in today's workshop. First thing is manual seeding. So, what is exactly what is seeding exactly? Whenever you use some particular model or let me just simplify it. Say if I want to write a code in order to generate random numbers from 1 to 10, what do you? You write something called random int. So what does it do? It takes up the range 1 to 10 and it generates a random number. It picks a random number out of it and it just displays on the screen. Right? That is what random integer or random int does. So whenever you run this particular program, what happens is that you get a unique number. Now, since LLM is all about generating a unique output at every point of time, if you want to optimize it by calculating the loss, and it is generating a random output at every point of time, will you be able to calculate the loss and optimize it? No. Right? So, what we are going to do is that we are going to see the model. So, what is exactly the now you have something called random integer. At the back end, like you are calling the function, right? So, what is happening? It is passing some parameters. So, in the background, when it is running the random image, it is basically governed by some particular algorithm or some particular function, right? You're calling it, you're using it. So, what you are going to do is that you are going to pass a numerical value to that function behind it. That whatever random integer is, random integer is governed by some particular algorithm. So, we are going to give a particular number. Now, what happens when you give a particular number to a particular function? You get the same output as so what we want to do is that in order to eliminate the randomness and check the loss and optimization, we will feed our model. We just put it on code and we'll answer to later. So when you feed that model, what happens is that randomly also will is using something called random or random integer. It is not going to generate a random output each and every time. It will use the number you provided in order to generate an output. Since the number is provided is constant, the output generated at each and every iteration will also be constant. So now you can calculate the loss and optimize it. The second thing is enumerate. How many of you know about enumerate? Okay. We all dealt with dictionaries in Python, right? So what are we doing here? We are taking a key and we are assigning something. This one you know what dictionaries are in Python? No? You know, right? How many of your first years can you just raise your hand? Sorry, second year can you raise your hand? Third year? Fourth? Okay. I'm happy. Since you already developed Python, I think you have an idea about what dictionaries are. So in dictionaries, what we do is we take a key and we assign a particular value, right? So inside enumerate what happens is that this particular key that you are taking will not be specified. Why? Because enumerate assigns the numerical values. Now the keys are numeric values. If I pass enumerate, it's of a comma b comma c. Then what it does is that it assigns 1 to a, 2 to b, and 3 to c. That is what it is going to do. So whenever you want to print the first element, you pass the key 1, so that is get a. You pass the key 2, so you get b. Something like that. So that is what enumerate will do. We'll look into how we are going to use enumerate in our code later. Moving on, what is the lambda function? Anyone of you know what lambda functions are? Sure. Exactly. They are basically so that is what I said. These are basically anonymous functions. They don't have any name. And apart from that, what is another specialty of this function? This function can be written in a single line and a short line. A single line function. We also look into how we are going to do single line functions in code. So yeah, this is how it is defined. So lambda is the keyword, and we pass arguments to a function, right? Followed by expression. So basically the part of the code that you want to explain as a part of that particular function. Yeah. As you can see, this is a small example of multiplying a number with 2. It is passing a number over here. This is x, and it just multiply it with 2. So whenever you want double lambda of 5, it just multiplies 2 with 5 and it brings the output. As you can see, this is a very simple kind of function, and this in case you don't have very big functions in your Python code, you want just reduce your size of your code, you can just use lambda function. Going on, soft max. Okay. Before I move on to soft max, so all of these functions that you see, softmax, multinomial, and optimizer, are three different functions that are provided by Torch. Torch is basically a library where you will find a lot of stuff related to ML and DL. It will also contain models that you can train, contain a lot of different things that we will be using today, something like modules, embeddings, etc. So, what is Torch exactly doing? I think that we want to calculate probabilities of the next token, right? So in order to calculate the probability, we need something in order to do that. So our softmax function, what it does is that it helps us calculate the probability of next character. In the behind, it takes your series of characters or data that are given, and it just calculates the probability. How it is going to calculate the probability is something we look into the later part of our session. I told you that whenever an LLM generates some series of text, what does it do? It doesn't provide the same output each and every time, right? So, in order to deal with that, what we are going to do is, we are going to use something like multi-norm. Now, what multi-norm exactly does is that it takes the letters which have a highest probability and it just displays them. Disclaimer, it doesn't create the highest probability actually, but for now, let's just understand that it is going to take the highest probability and it's going to display that. But and exactly that doesn't happen, we will see what happens in the later part of the activity. And the last one is optimization. Now, I told you that after we were doing the training of our LLMs, we want to do something like calculating the loss and optimizing our LLM model. Right? So, in order to deal with that, we have something called optimizer, which will optimize each and every layer of the LLM. We will look into what optimizer is doing, how it is going to reduce the loss and all of that stuff. Moving on. Oh, yeah. The first thing. Okay. Before we go move on to tokenization, I want to ask you one thing. Do you have clarity about what input we are taking? So we are going to edit a text. Can you show the input? So this is basically our input. As you can see, these are just different characters arranged in each other. But then, if you carefully look at this data, you won't find any numerical data. Okay, there are no numbers. They are only characters, like basically alphabets and characters, and only one like what special character which is backslash. This is the new line basically. So we have some punctuation marks, the new line, and some basically capital and small letters. We don't have any numerical data in our data set right now. So this is what we are going to use today in order to train our model. So I'll be sharing this file to you on WhatsApp. Just download it and wherever you are like in whichever folder you are working or doing work results, you are working directly, just copy and paste this particular file over there. Okay? So we'll be sharing you the input.txt file. Before that, we'll just look at this diagram over here. As you can see, the first part is a production thing. You can see the first thing which is BPE tokens. So BPE is something called byte pair encoding. We talked about character level, taking each and every character, predicting the next one. It is called character level encoding. We'll see about that in tokenization. But then, to give you a heads up, BPE or byte pair encoding is somewhere we take series of characters and we are going to predict what are the next series of characters. So we look into how we can split the word, how an LLM splits the word and say what like if you give it a context, right? Using that context, it is going to generate the next generate the output. So what it does is that it takes this context and it splits it into tokens. We'll look into that in tokenization, but this is what BPE is and what a character level encoding is. BPE is somewhere we deal with series of characters, character level encoding is somewhere we deal with series characters. So, of course, the next one the transformer architecture. Of course, it apart from self-attention and feed forward, it might contain a lot of different other stuff where there is something called feed forward loop. There, the feed forward network itself runs in a loop instead of giving it running the self-attention also. A lot of different stuff you can take and optimize the architecture and I go over to you. But then that was the basic architecture of LLMs. When it comes down to production environment, the transformer architecture is way worse than what we started. So the next thing is you can see, and you might have heard whenever you are dealing with LLMs and stuff, something called parameters. Right. So what are these parameters exactly? How do they help? If I have a very small model, why is it having less number of parameters? If I take a very good LLM, why is it having a large number of parameters? Well, all of your prediction actually, somewhere starts around parameters itself. Whenever you are trying to predict something, okay, I'll give you an example. Say if I have, how many of you know what the equation of a line is? Yeah, y is equal to mx plus t, right? So, okay. So y is equal to mx plus t, right? So instead of treating it as a line, let's just treat it as one single function. Y is equal to mx plus t. So this is basically where m and t are constant. As it. So x, the value of y is depending on x. Right. Now, the value of x, if you put it constant, and if you change the value of m, which is the slope, the equation of line is going to change, right? Y is equal to mx plus t. Now, if I change the value of m, and y and x are constant, if I change the value of m, will the equation of m, the line you get as the output changes, right? So your m is playing an important role in deciding how the line is going to look. Now, what I can do is that I can call my m as a weight. Okay. So basically what it does is that it helps in predicting my line for my given values of y and x. So if m is constant and y and x vary, I will get the same line each and every time. You get my point? So similarly, what if I get 1 billion m's? Okay. If I have only 1,000 number of m's, what are the different probabilities that I have? That's very less, right? If I have 1 billion m's, like basically the value of the minus, and then let's just assume that you have 1 billion number of m's. Each changing each very m will give you a unique output, right? So whenever you have large number of parameters, you can look into more number of probabilities of what the next character or next token. That is the reason why whenever the parameters are increased, the LLM might give you a better output, but it is not guaranteed. We'll look into that when we like. I have a challenge for all of you. I'll tell you all of this stuff over here. Right. We will understand what tokenization is. We'll share info that is we already shared to all of your WhatsApp group the input.exe file. Just download it, put it down in your working directory or research folder you are currently working in. I'll give you 2 minutes of time to listen. How many are you doing it? Yeah, let's see how you can import the input file. Yeah, if you see here, we have a folder section. If you observe here, we have a folder icon. And click on that. If you open the paper, you monitor all the folders. Just download the file that you send in the WhatsApp group and open your file folder. Just drag and drop it. Like, you're going to use the learning. You want to open. There you go. Did you follow me? Done? Anyone? How many of you are done with coding? You need some more time? Or any help? If you need any help, you can just call out, you will reach you and we'll solve it. If you copy the file onto your working directory, your folders that you are working on, these are not just data that we have our input. Yeah. So we just while doing, while you're talking to students, I have a small question for you. If you answer this question, I will pick something from here and I will give it to you. Okay. Which one is fast? If you are GP. GP. What you think GP? Raise your hand. Come on, guys. Raise your hand. GP is fast. GP is fast. Is that? Can you explain? Yeah. Like GPU is faster in performing multiple tasks in a quick time. Whereas to perform like bigger single task, CPU is faster. So compared to GPU, I guess CPU is better. So as I said to you, when you look at a very general point of view, CPUs are actually fast. The reason is that CPU has a very simpler hardware as compared to GPU. And on top of that, CPU only performs one or two tasks at a time. I mean, it depends on the number of cores you have. But then when you take a very general point of view, it can only perform one single task at a time. So, whenever you provide 1,000 tasks to provide, that is where the difference occurs. Inside the if you give a single task is completed very fast on the CPU as compared to the GPU. But then when it comes down to 1,000 tasks, this is where you will find something called parallel processing. If you look into how we are also going to do something called parallel processing in our code over here. So what happens is that whenever I give it 1,000 tasks at a time, depending on the like hardware or some limitations of the GPU, it performs 20 tasks at a time, which CPU can't. So when you give a large amount of data to your GPU, it computes it fast as compared to your CPU, which can compute only one single process at a time. Okay. Before we move on to what exactly tokenization is, what do you understand by the term tokens? Do you know what tokens are? No. Okay. So, when it comes down to the context of LLM, a token is something that it is going to use in order to predict something, or we are going to use tokens in order to predict. Right. So, how are we performing this something called tokenization? We are going to take, since we are doing a character level elements, we are going to assign each and every character one particular token or one particular numerical value. So, we saw something called enumerate over before when we are dealing with everything. So, what did it exactly do? It gave an integer value to any data we provided to the function. Now, what is the need of converting the particular character into or assigning it some numerical value? What the computers understand? Computers only understand numbers. They do not understand what characters are. So, what we have to do is that we have to find a way in order to like say how are we dealing with compilers and interpreters and all this stuff? What is exactly happening over there? You are writing a Java program, a program, a C program. What is happening? So what the compiler does is right, it picks up your code data in high level language. The compiler converts it into a lower level language. Now, what is this lower level language? It is something like an assembly code or basically binary form of the same code. What is the meaning of converting it into a binary code? The hardware, the system hardware can only understand numbers. Right? So, similarly, what we are going to do is that we are going to assign each and every character some numerical value that the LLM will use to predict the probabilities and stuff and all of that, and tell you how to achieve. That is the reason why we have to like take the data, kind of give it numbers and stuff. Like tokenization, when you're dealing with tokenization. So yeah, which is our next topic, of course. So yeah. Now, if you see this word hello, what do you exactly see over here? Here, if I feed this to a computer, okay, and before feeding it to a computer, in order for it to recognize how hello is represented, what we are going to do is that we are going to assign 1 to x, 2 to x, 3 to x, 4 to x, and 5 to x. Okay, of course, we have 2 repeated letters over there. So, once you give numerical values to all of the letters present in the word hello over here, we get something called embeddings. Now, tokenization is somewhere we split the particular word into characters and we give numbers. Okay. Tokenization is the part where you are splitting it. The part where you are assigning it numbers is called embedding. Okay. So what these embeddings store is that they store the semantic value or semantic meaning of that particular letter, which is not very difficult. To be more precise, I'll give you an example to understand. Say the apple grows on a tree, and I got an apple phone yesterday. These were different contexts, right? The word apple is being used in the first sentence and also in the second sentence. But the meaning of that particular word in each and every sentence is different. When I said the apple grows on a tree, I was referring to the fruit apple. Why? When I said the apple phone is what I got yesterday, I'm going to buy, I was referring to the company that is building that product. So, all of this semantic meaning that they are having is something which are stored in numerical values. This is also learned by the LLM trained data. This is where embeddings become important. So, referring to the context that you provide as an input, it is going to understand what you are referring it to. See, now you define apple as a food by looking at the sentence, right? When I say apple grows on a tree, if I remove the apple, what it is? This is something called tree. That is what defining that it is a fruit. And when I said I am going to buy an apple phone tomorrow, phone is something that is defining what my apple is saying, which is a company. So something like those semantic meanings and stuff will also be stored in part of memory and look into the context of the input. It will decide what my next output will be. It will look into the context and so. Right. Before moving on, so up till now we understand about what tokenization exactly is. So before moving forward, like since we understood the architecture of LLM, what we are going to do now is that we are going to write a small part of code where we will see how our input is being loaded, followed by how we are going to perform tokenization. Let me remind you that we are going to build a character level LLM, so our tokens will be individual characters. So yeah. There are popular particular input.txt on your machine. Okay. Now just create a new Python file where we'll be coding our LLM. So basically what I am going to do is that I already copy pasted something onto WhatsApp, which is Python created followed by my user name. So just keep that particular website open. It is like I'm going to dump all of the code over there or on the page over here. So what you can do is that you can just copy paste your code from here and you can see how what output you're getting. Yeah. So whenever I copy paste my code onto that particular website, then you're going to copy paste it into your laptop and you're going to run it. Before that, I explain to you what the code exactly is doing, so that you understand what the math or the intuition behind the code before actually running that part of code. So, first thing what we are going to do is that we are going to load the data. So, what exactly is data loading is that I am going to take like this is basically the text file we have, right? I am going to take all of this data into one specific data. Okay. For that, I am going to write something like this. Or I guess I already written it, just look at this. So basically, we have something like open input.txt R, and I'm taking this as a field. So what exactly I am trying to do is that I am trying to open input.txt file in read mode, right? So what exactly is read mode? I am trying to read the file. I am not updating any file content over there. So I'm just reading the file and I'm taking what all characters are there in that particular file. So in order to look at all the characters in that file, what I did is that I did something like x is equal to l.d. So what is l here? It's just an like instance of your file. So whenever you write dot read, it just reads the full file and it takes all of that text into this text variable over here. If I print the length of text, can you see a number over here? Somewhere around 11 lakh, 50,000. So these are the number of characters that we have in our data set. Okay. Be it including all the duplicate characters, be it A repeating so many times, B repeating so many times. These are the number of characters that we have in our data set. That is that. But then, how many distinct characters do we have? Can we judge it by using some data structure? Like how many distinct characters we have? Sorry, can anybody tell that? Like if I give you like I give you 1,000 numbers and I'm saying that it is containing duplicate data. One is repeating a lot of times, two is repeating a lot of times. And then I only want you to tell me the number of distinct characters it is having or the distinct numbers it is having. What are you going to do? I'll give you a topic to tell me the answer. Okay. Can you explain to me why you should use the set? So, as you said, when you are using a set, so if you are trying to, if you are trying to insert a data or insert the same kind of data into a set, it doesn't get inserted. So, in order to like, look into the number of distinct characters in our data set, we are going to use the same thing over here. So, as you can see over here, so since we saw that there are around 11 lakh different characters, we are going to use a set in order to see the number of distinct characters inside our data set. So what I did is that I took over here, you can see that whenever I pass an iterable to a function in Python, what does it do? And I give it something like it is wrapped around the set function, right? So that text is basically an iterable. It is going to iterate that particular text variable. It is going to insert that particular data into a set, right? Now, I have a set of distinct characters. Once I have a set, I am converting it into a list. Why? Because list allows distinct characters. I can use a list first. I use the set first so that I can see what are the different characters that I currently have. Then I'm converting it into a list followed by the sorted. Now what does this do? It just sorts my given the given list in increasing order. So basically, if I have characters, lowercase, uppercase, different characters, based on the ASCII values that are assigned in a value, it just sorts all of these characters. So now all of this stuff is stored into a variable called chars, right? So my chars is like at the end it is a list containing the different characters that are present in our text or in our variable text which is containing the data inside the file. Now, if I try to print the size of this over here, let's just see how much you get. As you can see, the number of distinct characters that are present in our data set is just 65. And on top of that, we don't have any numerical data. So, as I told you at the starting, we are going to build a very basic model today. So, the reason of me choosing this data set is this reason. The number of distinct characters that it has is just 65. This includes all the special characters, the new line, and also the different capital and small letters. Let's just see what are the different characters that it is having. So, you can observe this particular line over here. So these are the distinct characters that it is having, the space and exclamatory mark on the special characters, and then our capital letters followed by small letters. These are all the distinct characters that are present in our data set. Now, since we have all the characters we have in our data set, we are going to perform something called tokenization. As I told you earlier, tokenization is where we split our data set into individual characters and we assign it a numerical value which can be used later in order to perform the probability analysis process. So, for that, what I am going to do is that I am going to create something that we discussed earlier, lambda function, right? Before that, you can see that there are two lists over here, or two dictionaries, to be more specific. So these are the two dictionaries we currently have, right? So what are these dictionaries exactly called? I have something called S2I, which is string to integer. This is the dictionary that I am going to use in order to convert a string to integer. And this is a dictionary that I am going to use, I to S, integer to string, in order to convert numerical data to string. We will look into how we are going to use these two dictionaries in order to change from integer to characters and characters to integer. But then, as you can see, we use something called enumerate over here. Right? So, what is this enumerate exactly going to do? Right? It is picking up the numerical value which is stored in I and the character value which is stored in CX. Okay. As you can see, if I pass all the different characters into enumerate, what happens? My space is given the value of 1. My exclamatory the dollar sign is on, right? So, similarly, if I this is what is present inside an enumerate. Like the highlighted data over there. 1 comma A, 2 comma B is what it contains. So when I say I comma C in enumerate, I take up the numerical value in that particular tuple and C takes the character value inside the tuple. So inside I, it is 1 and inside C you have 8. Only for the first thing. In order to iterate through all of the tuples that are present in my enumerate, I am going to use a for loop. Okay? Any part of the code is confusing or you want to slow down, just raise your hand, I'll explain it to you once. Fine? So, I contains the numerical value and CS contains the character value. So, changing to I name, what you are doing is that you are assigning the key as a character and the value as an integer. Because you want to convert a string into an integer, right? So, my key values over here are characters, right? My values of those particular keys are integers. Similarly, in order to convert an integer to a string, I am going to take my key values as integers and my character value, letters as values to that particular key. These two are the two dictionaries that we are going to use in order to convert a particular string into integers or a string of integers to a list of integers to a string. So let's look into how we are going to do that. Over here, you can see that I wrote two lambda functions, encode and decode. So, what is encoding? Encoding is basically the process of converting a string into numerical value. Right? So, I mean, it's kind of famous in detective movies and stuff like encoding data. Kind of fascinating. So, what do they exactly do in encoding? They convert your particular normal string into a hidden type of thing that humans don't understand. So if I give you a string of integers, will you be able to understand what that particular thing is exactly telling? No, right? So what we are going to do is that we are going to encode our string into a list of integers. How we are doing that? So we are calling our dictionary, which is into integer, along with the like keys. So if I take a string, which you can see over here, I am Aditya. It is what it does is that it picks up I and it takes its value inside string integer, which is SY. In this dictionary, it takes I and it takes the value of I, whichever is present, and it changes that into an integer and it appends it to a list, which is code, which is something you can see over here. Because I wrap this around square brackets, this end, at the end, what I am going to get is a list. Integers. What are these integers? These integers are basically the value that I assign to each and every character. And similarly, in order to convert a list into a string, what I am going to do is that, of course, the first thing I am going to do is that I am going to convert the given list of integers to list of characters. Now, since I have a list of characters, I cannot just display that. Right? I have to convert it to a string. So what I am going to do is that I am going to use something called dot join. What this basically does is that it joins all of the characters present in the list and it gives you an output. This is a very simple character level tokenization. Now we'll just understand it by using an example. As you can see over here, this is basically the string that I am providing, which is I am Aditya. I am asking it to convert it into a string of integers, so this is what it did. As we saw before, one is paper. So after I, what is the character? It is a string. So this is given a value 1. And if you count here, the small a is given a number 47. That is given by a string 47. So we converted the like series of characters into a series of integers. That is what we do. Now, if I remove 39 over here, what will happen? Only a single character is disappears, which is A. Right. So this is what I meant when I said character level encode. Each and every character is given a particular integer. This is not a very optimal approach when it comes to computing things. The reason is that whenever I am dealing with a large context, I don't want to see each and every character. What I want to see is series of characters. Like I told you before. If I took the value of 3 or if I took the value of phone as a full unit, that is when I will understand what my app is saying. If I treat 3 as 4 different characters, then will I be able to map down the relation of the apple? Or like the word apple? No. So this is a very basic approach to tokenization. But let's look at an example of white pair encoding also. As you can see, I'm using this lambda function encode over here in order to convert it to a list of integers. But I'm using decode in order to convert all of these integers to characters, which are printed over here. Before moving forward, let's look at an example of byte pair encode. So byte pair encode, as you can see, those 5 lines of code is where we are going to do byte pair encode. This token is basically a very popular package used by your chat GPT in order to perform tokenization. Of course, nobody will give us the ChatGPT is going to use this token in order to perform any analysis regarding tokenization. So let's just see what exactly is happening over here. Let us see. Yeah. So first of all, let's look at this number over here. What is this number exactly? This, this particular number. These are the number of tokens that particular tokenization algorithm has. How many tokens did we have in our tokenization? Whatever tokenization we were doing, we have only 65 different characters or 65 different token IDs to be more specific. We have only 65 distinct token IDs which represented 65 different characters. But your TikTok has 50,000 tokens which are distinct. So, whenever if the number of tokens that I have increased, or the number of ways of which I can identify different tokens increases, me training the model will become more efficient. That is what I meant initially when I said increasing the data size or optimizing the code keyword. So we only dealt with 65 different characters. This token is dealing with 50,000 different tokens or 50,000 different strings of characters to be more specific. Now, if I convert this hello there, I am Aditya into series of numbers, what is going to happen is that it is going to give me this string of integers. Okay. What did we see before? For I mean, like, here is the length of word, the length of sentence is large, right? So if you have gotten more number of tokens, right? Then I got very less tokens. I previously saw that I just wrote I am sorry. Here I wrote only 3 words. I am Aditya. But then what is the output? The output is a very large list, right? So what is happening? I have to complete more because the number of tokens I have now are more. So my computation increases because I have more number of tokens. But then if you look at what byte encoding is doing, right? It is creating series of characters that we saw before as one single unit. That is the reason why it is giving it one single number. Let's just play around with this series of numbers before that. Yeah. I just copied this series of integers into my default function. This is common. I think the list always great for this thinking other way around. What if I remove the first token? Let's just see how much of our sentence disappears. Right? What is it? Previously, when I removed, I mean, previously, if you saw, I removed the letter A or I from my output or from my integer list. One single character disappears. But now, if I remove one single token which was in the starting of my string, one whole word disappears. So what the stick token doing is that it is assigning the whole word a particular token. That is the reason why whenever I remove that token ID, hello is not getting hello is not doing. Now, since hello is a very common word, like you can, whenever I give a very large context to a particular LLM or a train, it looks for patterns is whenever I'm performing tokenization, if I see the word hello, I want to assign. I will assign it once in a token. Because I don't want to take each and every character once. Because hello is something that is very prominent in the text. So what I will do is that I will provide one single token as you can see over here. If you see artificial is not something you might find in a data set, which is frequent. Right? So how do we treat artificial exactly? Let's look at that out. Let me just remove the last token and see what it is saying. As you can see, the last token was storing two values, y and a. So what is my token is like what happened is that since the data set or the omnibus data that my tokenization algorithm was trained on had y a continuously somewhere. It just creates a series of characters y a once in a token. So, in general, like what you see in big companies or the production level GPTs is that characters that are frequent or series of characters that are frequent are given one single token, while characters that are not prominent are like now you can see that the string RHWS is not something you will find in a very large data set that is prominent or frequent. So what did it do? It divided into sections. Now if I take out this token value over here, it is going to remove TH. Why was something related to the last token? TH is related to this token that I just removed. So it is
we are going to prepare our data. Since now we have our data, what we are going to do is that first thing is that we are going to convert it into numerical values, of course, so that the computer will understand it. But then we are going to train our LLM also. So in order to train a particular model, what we try to do is that we are going to split our data into two parts. One for training our LLM model, second one for validating it. Okay, validation is somewhere we deal with loss and stuff, but training is like inside training we are going to split. So inside training is where we are going to split our present data into two parts, which is the training. So for my LLM model, what I am doing is that I am splitting the data into two parts, 90% for training and 10% for validating it. Usually the split is 70 to 30, 70% for training, 30 for validating. But then since we are stuck with very small data set, this is what I am going to do. I'm going to take most of the data set to train it and only 10% to validate and optimize it further. Let's just write, let's just see how it is being executed as code over here. Yeah. Before moving forward, let me just tell you what we are doing over here. We are using something called a tensor. Okay. So tensors are similar to arrays and lists inside Python. But then what is the add-on that you get with tensor is that okay.
స్ట్రీమ్లో పోతాయి ఇప్పుడు ఎనేబుల్ చేస్తుంది.
Give me 2 minutes, I'll be back.
స్ట్రీమ్ ఇంపార్టెంటా సెషన్ ఇంపార్టెంటా? సెషన్ వాళ్ళకి స్ట్రీమ్లో కావాలంట. ఏం చేయమంటారు?
Yeah. Have you ever used list in Python?
ఏం చేద్దాం చెప్తున్నాను.
Can somebody tell me
స్ట్రీమ్
what are the
సెషన్
characteristics of
ఇంపార్టెంట్.
list? What are the properties of list? Yeah.
చెప్పు.
Yeah.
అట్లా స్ట్రీమ్ చేస్తుంటే ఇష్యూ వస్తుంది. స్ట్రీమ్ చేస్తుంటే నా కోడ్ రావట్లేదు అంటున్నాడు. వాడు కోడ్ రన్ చేస్తున్నాడు. వాడు స్క్రీన్ ఉంది కదా, స్క్రీన్తో మిర్రరింగ్ ఇంకా ఎక్స్టెండింగ్ స్విచ్ చేస్తున్నాడు. చేసినప్పుడల్లా నువ్వు ఇక్కడ
List is a mutable and dynamic ordered list. Like characters should be in the ordered way.
Allows duplication and can store values of other data types. Now, what are the properties that you are saying? What are the properties that we said till now? This is mutable, contains different data types. Yeah, one more. Dynamic. Right? Yeah. Different data types.
What do you want? Like curve back. What will be like? Curve or back? Curve. Yeah, you can have it. Yeah, now that was the part of Python, like the basic Python that we use. Now we are introduced to arrays and tensors. Can anybody tell me what is the difference between an array and list? Now, this time, I guess you are going to have something like, Ishet, yeah. What is the difference between list and a array? Yeah. Yeah, we got one answer from here. Array stores homogeneous data, right? Whereas list stores heterogeneous. That means multiple data types can be stored on the list. Do you have any one? Different one.
Array is static and list is dynamic. And this is the name for array is this, and this is the name for list is so, because due to data type, this has display for digital and I can store only single data type. So,
We have one more question. There is no difference between vector and a tensor. Vector and a tensor. First, we go with vector. What is a vector? You know what a tensor is?
I guess we are only left with one or two goodies, so use that opportunity properly. Yeah, we are only left with one t-shirt. I guess that is going to be some other purpose. Okay.
Like you said, vectors are something that store both data and direction. Okay. So, if I want to represent direction in the form of numerical data, that is where embeddings come. So, what tensors are exactly is that tensors don't contain any numerical value. The only thing that they store is that they store the direction of like that what you're providing. But then let's just be more practical about how it is being implemented in our code over here. we are using tensors in order to, embed data that is helping me to recognize that the particular character is present at this particular location. Whenever you are dealing with LLMs, or how many of you know what vector databases are? Okay, can you tell me what a vector database contains?
Vector database contains the vector embeddings that the model can use. Other difference.
So yeah, as you said, it basically contains the vector embeddings of each and every data that is being stored inside a vector database. So whenever I store some particular data in a vector database, along with the numerical data, what is stored is that it is the direction of that, or to be more precise, the positional arguments of that particular character are also stored. Using these positional arguments, I am going to judge what is my next character or what my next token is. I'll show you.
ఇంకా చాలా ఉంది ఇంకా నీకు అదే చెప్తుంది ఏం ఇష్యూ లేదు మస్తు టైం ఎంబెడింగ్స్ అయిపోతుంది
టోకెనైజేషన్ ఎంబెడింగ్స్ అయిపోతుంది. ఇక్కడ బ్యాచింగ్ ఉంది. బ్యాచింగ్ తర్వాత కొంచెం సెల్ఫ్ అటెన్షన్ గురించి చెప్పి ఆపేస్తాం.
ఓకే, నీకు టైం చూసుకున్నారు ఒకసారి, టైం చూసుకొని
సరే, ఎందుకంటే ఆపకండ్రా మధ్యలో అస్సలు బాగా అయిపోయింది. So we understood what tensor is. Tensor exactly is, right? So tensor stores my positional like encoding, or where exactly it is stored. Let's just not go deep and crack our heads. But anyways, so we are encoding our particular text and we are just storing it inside a tensor. Now what does encode do? It converts the given characters into integers, right? So what is text over here? This text is a variable that we used in order to store all the file contents that we read. So, in order for me to create a tensor, so basically what I am trying to do is that I am using this lambda function encode over here, where I am going to pass my whole data, and each and every character is converted into its respective numerical value, and it is stored inside a tensor. Now, one more thing what I would like to clarify is that inside a tensor, it has to contain only data of same data type. So, what is the data type that I am giving to each and every integer that I am storing inside it? Long. So, whatever data is stored inside my variable data are numerical values, and each and every numerical value is related to one particular character, as we saw in tokenization. So let me just print the first 1,000 characters of my list or tensor data. Let's just see what we get. So as you can see over here, my text is like my numerical values are wrapped around something called tensor. This represents that the array of integers that are over here are all tensor values. So inside our data, which is input.txt, what was our first character? Capital B. What is the value of capital B? 18. What the next character is? Oh, sorry, this is. Oh, I'm very sorry. One second. So the first character is F, right? Capital F. So this capital F is given the value 18. Next is small I, which is given the value of 47. So what it did is that it took each and every character, it used our lambda function before and it converted into a numerical value. Now we have the numerical data related to each and every character present inside our data set. Now, what we are going to do is that, as I told you before, we are going to split this into two parts, which is the training data followed by our validation data. In order to do that, I used a little brain, and what I did is that I took the length of text. Now, what I am going to do, I am going to take my data and I have to split it into a 90% and a 10%. So what I am going to do is that I am going to see what is the size of my data set. Based on what my size of data set is, I am going to check like how much does 90% contain and how much does the 10% contain. So what I did is that I took the length of text again being my input.txt, all of the data present in input.txt. I checked the length of text and I multiplied it with 0.9. 0.9 is nothing but 90 by 100, 90%. Okay, so I am taking the length of this text and I'm multiplying it with 90% in order to get one particular value, which is n. Now what I am going to do is that I am going to take this data, which is basically a tensor, and from the first value, which is the 0th value, to n. N is basically 90% of the data, right? So starting from 0 to n is the 90% of the data. So what I am going to do is that I am going to run it from 0 to n, and each and every character from 0 to n is being stored inside my test underscore data. So this contains my test data, followed by train underscore data, followed by test underscore data. Test underscore data basically contains the remaining 10%, which will start at n and it will end at length of text. Fine. So this is the how we are going to split data that we currently have into a 90% for training the model and 10% for validating it. Finally, I told you, we are going to do something called seeding the model. So whenever you seed a model, the output it generates now is not random. It generates the same output each and every time, though you are going to use functions like random integer or picking up random numbers or stuff like that. So I'll give you 5 minutes. So you are going to build your model, right? We covered up till now, we covered the first part, which is data loading and tokenization. I am going to copy paste this code onto my website over that I gave you. So before me starting this session, I actually posted a small web page which is a code base. You can just open the website now and just copy paste this code over there. Create a separate file called model.py and just copy paste the code that I provide to you right now.
So it's time for us to wake up and do the work. Like you'll be copy pasting the code that you need to do. Just copy that, paste it into your code base, and run it. So see how it is working. Like what will be the output of each and particular line, so that you understand. We will be explaining parallelly. Yeah.
ఇంకా లోకల్ వస్తాయి లోకల్ అంటే కాపీ చేసి పేస్ట్ చేస్తే మళ్ళీ పుష్ అయిపోతుంది. డిస్ప్లే అయితే నేను కాదు. లింక్ లేదు పెట్టినాం స్టార్టింగ్. ఏం వెబ్సైట్ లింక్ పేస్ట్ ఇక్కడ ఉంది. ఆ వెబ్సైట్ రా వేరే దాంట్లో వేరే ట్యాబ్ లైవ్లో
If you see the code is live on the website, open the link from your WhatsApp that we have sent and just copy paste that. For any help, just raise the hand. We will be there for you.
In case you haven't understood any part of this code, you can just raise your hand, we'll come to you and we'll solve it out. So, yeah. I'll be sharing you this website link once again. This is basically my code board where I will be copy pasting the code, which you can copy and paste it onto your code editor and run it. I shared the link once again for all of you to check out. Just open that, you will find like all of the code that I have written on my code board, which is that particular website over there. You can just copy paste it function. How many of you guys are hungry? Okay. Before moving on to lunch,
బ్యాక్ అయిపోతుంది కాపీ చేయడానికి తెలుసు కాపీ అవుతుంది చేసిన చాలా మంది చేసినారు నాకే వస్తుంది వాళ్ళకి ఇస్తాను పోతుంది వాట్సాప్లో పెట్టేలేదండి వాళ్ళు అక్కడ పని ఇస్తలేదు కంట్రోల్ సి కొట్టి అది వాళ్ళకి వస్తలేదు అక్కడ చూడవచ్చు ఎక్కడ రెడ్ యాక్షన్ తీసుకుంటుంది
before we move on to batching, which is our next part, and also a little about self-attention and probably leaving for lunch. I have badges with me. If you answer my questions, I'll give you a badge. Okay. So my first question is that what is anyone over there doing? Can somebody answer me that? What is enumerate exactly doing? Okay. Assigning English to everyone. Numeration. As we said, enumerate is encoding. Can anybody tell me what encoding is and also what decoding is?
Encoding is easy, I guess. Encoding and decoding.
No.
Okay, let me show you something.
Aren't you fans of Sherlock Holmes, Mission Impossible? You don't know what encoding and decoding is. Probably what encryption and decryption
At
is.
least by seeing this encoding. Seppanra. Dana.
No one.
I guess they don't want badges.
Such a boring problem.
Wait, discourage cheyega.
Just look. You want to tell what encoding and decoding is?
Converting string to integer in encoding. Decoding means string to integer to string.
Basically, encoding is nothing but converting a character into a number, because computer doesn't understand our languages, right? Like English, Telugu, or something else. It doesn't understand that. What computer understands is just binary, zeros and ones. So we need to convert a character into a token or like a number. This is again converted to a vector called vector embedding. The process is called embedding. Okay, yeah. Okay, are you done with testing the first code? How many of you have implemented it? Yeah, I find many hands actually. Yeah. Any other?
In case you have any doubts, you can just ask it out right now. In another 1 minute, I'll be moving on to the next part, which is batching. Okay. Done, guys? Let me first tell you theoretically what batching and block size is. So, when you actually change the whole data into numerical values right now, right? But then, are you going to feed the whole data to the LLM at a time? No, right? So, what we are going to do is that we split, yes, we did split it into training and testing data. We're gonna pick up this training data right now. We're gonna divide it into more subparts. Okay, so that I give it a list of some 8 characters, and I give it the first character, and then I ask you to get the next one. Okay, I'll tell you exactly like how we're gonna do that soon. But then let's just say currently I have guys at the end. So I have my training data right now. So what I am going to do is that I am going to pick up a random pool of 8 continuous characters. Okay. Now, why continuous characters? Because you have to train your ML model to predict the next token, right? So we are going to take a pool of some 8 characters. 8 is just a number that I am specifying right now, which I will be writing in code. But then you can change the 8, you can upscale it to 32, you can downscale it to 4. But then changing this number actually, affects a lot when it comes down to your LLM providing an output. The reason is that your block size, which I confined it to 8 right now, is what determines the number of characters that I can predict at a later point of time. Now, if I have only eight continuous characters, and I'm asking you to predict only 8 characters of data. Now, isn't that very small? Because I'm taking the first character and I'm predicting the next one. I'm taking the first two and I'll predict the next third one. This is a very small amount of data that we are going to predict. But that is not how how an LLM should work, right? Your LLM should be able to output a larger amount of context where sentences of data are related to each other. But since I told you, because of hardware confinements and a lot of other things, we are as far as our main code is concerned, they will find our block size to be 32. That means 32 individual characters is what 32 continuous characters is what we are going to train our model on. But then, in a usual sense, it is not only 32 characters, because I am saying characters every time because are tokens of characters itself. But then when we deal with larger amounts of data, you can exactly differentiate what tokens are, what series of characters are, right? So then this is not prominent in our model. And on top of that, since our block size is less, the amount of context on which our LLM is learning is also limited. But then it doesn't mean that this particular LLM is not going to learn patterns. It is going to. But then your output will not make very much sense. But then yes, it will predict some patterns. It will learn some patterns and it will generate an output. So your block size plays a very important role in deciding your output context of your LLM. If it is very low, then the amount of data it is being trained on is very less. Or though the data is more, the patterns that it is seeing is not long term. The amount of patterns that it is seeing is confined to a very small space. So, if the block size is more, then my LLM can see a larger amount of context at the same time, and it can predict what my next character is. I hope I'm clear about what block size is. Now, previously we took a tensor, right? Apart from tensor storing only single numerical data and all of the other stuff it being differentiated from arrays and lists. The main advantage with tensors is that it provides something called hardware acceleration. Let me tell you what that exactly is. If you want to perform mathematical operations on a CPU, a 10% will give you a faster output. But then if I ask you to multiply a whole matrix, do you think the output will be fast? No, right? So, in order to solve that issue, we are going to use tensors along with GPUs. Tensors are something that provide hardware acceleration, and on top of that, what they do, they perform because we have hardware acceleration, and this hardware acceleration is something provided by a GPU. Your mathematical operations become fast. I hope I'm clear. So that is the reason why we are going to use tensors. Now, I told you about block size and what we are going to do inside a block. We are going to take a single character and we are going to predict the next token or the next character. So, whenever I want to train my model, what will I try to do? I am going to take, say, why should we use tensors is what I want to clarify on. So, what this batch size exactly specifies is that how many arrays where each array length is block size. Okay, block size being 8. How many such arrays can I compute in one single iteration? Okay, that is batch size. I'll show you it in code. That is when you will understand more clearly. Up till now, let's just say I have 4 arrays, and the size of these arrays is constant, which is 8. I want to perform mathematical operation on these 4 arrays at once. Will I be able to do it on a CPU? No, right? Because I asked you a question before and I clarified it saying that on a CPU you can run only one particular process. So, if you run that on a CPU, it has to perform the mathematical calculation on each and every array, right? That is what a CPU will do. But then when it comes down to a GPU, it performs mathematical calculation on each and every array of those 4 arrays at the same time. Don't you think the time is reduced now instead of using a CPU if you are using a GPU? Yes, right. So that is the reason why we are going to use tensors in order to speed up the mathematical calculations along with GPUs. Let's just show you, before moving on, these are some standard definitions of what batch size and block size are. So what exactly is block size is that block size sets the maximum length allowed inside a single sequence. We'll look into like it can be number of tokens, characters, anything. And what exactly is a batch size? Batch size sets how many separate data samples or sequences you are going to provide to that particular LLM model in order to train it on. Okay. Let me show you that in code. Yeah. As you can see over here, what I am trying to do is that I created a function called getBatch. So what does getBatch basically do is that it basically creates a batch of 4 arrays because my batch size over there is set to 4. Okay, and my block size is 8. You can assume something like, you know how a 2D matrix looks, right? So if I took a 2D array. So if I took a 2D array and if I set the size of 2D array is 4, that means I am going to have 4 different arrays. So this is what my batch size is basically specifying. And what my block size is specifying is that what is the length of each and every array inside that 2D array. That is what we are going to map around for now. That is what exactly we are going to do also. But so as you can see here, what I am passing is that I am going to use this function in order to get a batch of data from my data variable. Previously, what did we do inside data is that we converted all of our characters into numerical data. Each and every token was assigned some numerical value and it is being stored inside data. Right? So we are going to take train data and we are going to assign this data to training data by default because training is the maximum part because 90% of the data was used in training it. So I default took it as train data. When my split is train, split is basically a string. Okay. So whenever split is given a value of train, then it is set to training data. Else it is like forwarded to test data. This is what this line is specifying. So now in here inside this over here, if you observe carefully, I wrote get batch of train. That means my split is assigned the value of train. So what is the data that is being stored inside data? Training data. Now what I am going to do is that I am going to take ix being the initial value of x that I am using. So, okay, before moving on inside batching, there is something called labeling. How many of you know what labeling is? No? Okay. When we are dealing with training a model from scratch in ML, and I asked you to not to take any predefined data set. Instead, I ask you to scrape data from an actual website. Scraping is nothing but like taking up data from a website that is hosted basically on the web. What are you going to do? You are going to take, say, I am like gathering information about different products on Amazon. You are going to take all the shoe data and you are going to give it a value shoe. You are going to take all the values of like all the shirts present on Amazon. You are going to give it a value shirt, right? Labeling is something similar to that. What we are going to do is that we are going to label whatever data we have so that I know what the data is exactly representing. Okay. This labeling is what we are doing inside badging. Let me exactly tell you how we are going to do that. So inside labeling we saw that we know the input, which is the label that you gave, which is the value of product that is being stored inside that particular name. And the name is basically your output, which is a shirt or shoe or whatever it is. So IX is what is IX doing is that it is going inside our data and it is going to pick a random integer, random position from our data value. What is our data storing? Our data is storing all the numerical values that we converted using the input.txt, like converted from input.txt, right? So what is it going to do is that it is going to fetch how many characters? A size of 4 random characters. My data variable is containing the numerical values of each and every character present inside my input.txt, which is around 11 lakh characters. Each and every character is assigned to a numerical value and was stored in data variable. Right? So, using this data variable, what I am going to do is that I am going to pick 4 starting values. As I told you, we want 8 series of characters. So, for those 8 series of characters in 4 different arrays, what I am first doing is that I am taking the first character in each and every array. So that now if I have the first character, I can predict the next 8 characters using the data data variable. Right? Let me be more clear. If I have 10 different numbers and I ask you to make 2 arrays and the values inside this array should be continuous inside like from what you saw in the previous array. So what are you going to do? You are going to pick up some starting position and you are going to iterate forward, right? So this starting position is what I am defining for each and every array using initial ix, which is initial x. Here, the reason why I subtracted block size here is that block size is a series of 8 characters, right? Block size is 8, right? So, what if my random integer function gave me the last number? I should still be able to look for 8 sequential characters, right? So what I did is that I took the length of my data and I subtracted block size so that I can eliminate that edge case. Where if that random function or rand int, as you can see, picks up the last character inside my data, like data variable, I should still be able to take up 8 continuous characters. That is the reason why I subtracted it here. Okay. Now we have 4 different initial positions. What we are going to do is that we are going to take x, which will contain my inputs, and my y will contain the outputs. So this way of mapping my input and output is called labeling. This is what we did here. So I'll just print and show you like what exactly we are doing over here. So what did we do? Let's just not focus on what is happening inside x and y. We are just like creating a tensor x and y which contains some particular data which we don't know yet, and let me just print them for you. Interesting. So this is basically the size that I was previously talking about. So this contains like dimensions of 4, 8, 4 different arrays where each size of array is 8 characters. This first tensor that you see is the value of x, and the second tensor that you see is the value of y. Okay. Whenever you're trying to train a model, you basically provide inputs and outputs, but your model learns the pattern of how the output is related to the input, but it does not hard code itself that whenever I see this input, this should be the output. We'll look into how this happens at a later point of this workshop. But up till now, let's just understand that somehow the LLM is going to learn a pattern in order to predict the output via the given input. For now, as you can see, my inputs are the value of x and my outputs are the values of y. So 24 is my starting position. How did I justify that? I told you that ix is going to contain my initial values of x. So here in data of inside my data, what I am doing is that I am going to take the initial value I, which is basically the first value in the values in ix. So first thing that happens is that this loop runs for every I in ix. So ix is basically your starting position of each and every block. Now, what I am going to do is that I am going to iterate from I to I plus block size, where block size is 8. Right? So now I'll get 8 different characters over here, which are sequential, which are continuous inside my data variable. So these are the list of integers that occur continuously inside my data, where 43 is my starting position. Similarly, what we are going to do inside y is that we are going to take up, like y is something where we are tracking outputs, right? So what we are going to do is that we are going to take the first character and we are going to predict the next one. And we are going to use the previous 2 characters. Now, basically what we are going to do is that first character is something we can provide at random anything. Using that first character, our LLM will predict the next character. Now, how many characters do you have in total? 2, right? Using these 2 characters, I am going to predict the third character. Using these 3 characters, I am going to predict the 4th character. This is how our LLM will work. So that is, in order to do that, what we are going to do is that I split it into something like this. So 24 is my first character. And what is my second character? It is 43. 43 is what is present in our data, right? So what is 24, like what is the position of 43 in y? It is our first character, right? So using the first initial character of x, I am going to predict the next character, which is 43. Once I predict 43, I have 24 and 43 with me. What should I predict next? 58, right? What is the second character over here in y? 58. So this, like whatever I told you verbally, I put it down inside a array and I'm showing it to you. Using the first character, I'm predicting the next one. Using the first 2, I'm going to predict the third. Using the first 3, I'm going to predict the fourth. This is going to happen up till 8 characters. After 8 characters, you're gonna start a new. You're gonna come to a new array, and you're gonna start predicting the next character. But let me ask you one thing: if this happened in like LLMs that you use today, would you get optimal outputs? Because your context is getting lost, right? whatever you predicted, the first 8 characters are being replaced by a new array. Don't you think the previous context was lost? This doesn't happen in general LLMs. What happens is that you have something like a sliding window type of thing. So that your previous, your next generated token is added to that previous token, and the first one is removed. So it just slides like that, and your next tokens are predicted using the previous context. So your context is not lost when you are generating some particular output using general LLMs that you see here. But then context over here is lost. I mean, I'm not solving this problem right now. I'll do that in a later part of the stage. But for now, as you can see, we have a 2D array where each and every array is having these list of integers over here. And we are predicting the next character using y. As you can see, I created this particular batch over here, batch of data, and I'm returning my xy, which are stored in xb and yb. And I'm going to use this xb and yb later on in order to train my data about predicting the next. So this is all about batching. Let me just copy paste the code for all of you about batching onto the server. You can move to lunch after copy, like understanding what batching is from the code and just pasting it into your like LLM that you are building. So yeah. Self-attention we will look into after having our lunch. You can leave for lunch at 12:30. Before that, just store this code with you.
Okay, guys, is there anybody here named Shujit? Yeah. Thank you.
Before that, I would like to specify some important things too. These are basically hyperparameters, or I am predefining some parameters for my LLM, which are, of course, my batch size, my block size, my number of iterations and stuff. So I want you to copy paste this part also. While exploring the code of LLMs, we will talk about each and every variable that we see over here. So yeah. In case you have any doubts, you can just raise your hand. I'll come up to your place and we can sort it out.
ఇంకోటికి అటెండెన్స్ కోసం ఫీడ్బ్యాక్ ఓపెన్ చేయాలి వెబ్సైట్లోనే ఉంటుంది షెడ్యూల్ ట్యాబ్లో ఫస్ట్ హాఫ్లో సెకండ్ హాఫ్లో సెకండ్ హాఫ్లో ఫస్ట్ హాఫ్లో సెకండ్ హాఫ్ రాకపోతే ఇష్యూ సార్ సెకండ్ వెరీ సిస్టమ్ ఉంటుంది చెప్తాను ఇప్పుడు సెకండ్
I've already copy pasted the code for all of you. You can just throw it into your LLM that you are currently building right now. In case you have GPUs, I would love to suggest you to play around with batch size, block size, and training rate, and also the embedding size. I mean, probably at the end of today's session, so that you will see a lot of different outputs when you change all of those values. The reason is that your context might grow. It affects the training somehow. That is what you have to figure it out. Your batch size, your block size, or the number of embedding values that you have, the number of heads you are taking. All of this matters. These are set to very low values because not everyone, including my system, has a GPU, right? So yeah. Are you hungry? You want to go for lunch? I don't know sleeping. Okay, I'm just joking. You can leave for lunch. Please come back at 1:30. You can have your lunch.
Okay, like for the second half, we will be having some conceptual things, quiz along with goodies, and you will be provided attendance in the second half. Okay, yeah. So make sure you attend the second half of this session. Thank you. Have your
Second
lunch.
half is somewhere we are going to learn about self-attention. It is something that is very important because that is what is defining your so so see you in the second half. You are going to learn a lot of stuff, lot of new stuff in second half. Yep. See you guys. Bye bye.
సెకండ్ హాఫ్ మంచిగా సెటప్ చేసి పెట్టాలి అసలే దీంట్లో గూగుల్ కొలాబ్లో ఏమంటారు పారామీటర్స్ ఎక్కువైపోతుంది మెమొరీ ఎక్కువైపోతుంది సాంగ్ పెట్టిన ఏ దోస్తి అక్కడ అవసరం లేదు అది బెఫా నోట్స్ నాది రోడ్డు మీద ఏ కాదు 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 రాయల్ ఎన్ఫీల్డ్ పోతుంది రోడ్డు మీద దాన్ని చూసుకుంటా
చూడా నువ్వేనా శివప్రకాశ్
బాగుంది మౌస్ లైట్స్ ఉన్నాయి దాంట్లో
గేమింగ్ మౌస్ ఆర్జీబీ
ఒరీ
రెడ్ గే లైట్స్
డెస్క్టాప్ ఇదేంటి ప్రోగ్రామబుల్ ఇవి
తెలియదు అది కాదు శివప్రకాష్ అది ఆ మౌస్ కి ఓన్లీ ఫ్యాన్స్ ఉంటుంది
మౌస్ కొంచెం
ఆ మౌస్ కి ఓన్లీ ఫ్యాన్స్ ఉంది
ఓన్లీ ఫ్యాన్స్ ఉందా ఎంత బాగుంది చూడరా ఇది చెప్పు
విశ్వ డూయింగ్ డ్రగ్స్.
ఓపెన్ చేసి ఉందా
ఎస్ ఎస్
Can I get a
ఓపెన్ ఉంది కదా
అయితే ఇంకో నా సేమ్ ఇంత ఉంచుకుందా నువ్వు ఆ నిమిషం మాట్లాడి నేను నా ల్యాప్టాప్ దగ్గర నేను ఉంటారు మారుతుందా మధ్యలో మధ్యలో మారుతుందా కంప్లీట్గా అంటే నా వల్ల కాదు స్టీఫెన్ హాకింగ్ అంటే కాల్ చేతులు పని చేయవు కదా కాల్ చేతులు పని చేయట్లేరా నాలుగో చేతికి ఏమైంది వాడికి అది పని చేయదు అంటే ప్యారలైజ్ అయింది ఓన్లీ మసిల్స్ పని చేయవు
మజిల్స్ పని చేయకపోతే
తీసుకెళ్ళింటారు
అది మజిల్ బోన్
చూసినట్టేమో తెస్తే ఏం చేయలేదేమో అరే నోరు ముఖం పనిచేస్తుంది కదా ఎవరో ముఖం మీద కూర్చోబెట్టుకున్నా అవునా
డ్రెస్ పైన
Would you go to Epstein Island if you had a chance? అన్నా ఇప్పుడే
అందరు నీలాంటి దొరుకుతారు అక్కడ బ్లాక్ నికల్స్
చెప్పు డాకు డాకు మహారాజ్ డాకు మహారాజ్ అంట పుట్టుకొచ్చి పెట్టుకోండి ఇంత పెద్ద డాకు మంగళ సింగ్ అరే అర్థం సార్
అది ఉంటుంది చూడు లాగిన్ చెప్తా
వచ్చు ఒక పాట కావాలి మనకు 7 years
లూకస్ గ్రాహం
ఇది పనిచేస్తుంది చూడాలి సార్ ఆన్ చేసి
రే ప్రైవసీ పోతుందిరా రే, కెమెరా ఆన్ చేసి పెడుతున్నారు అండి నీ దాంట్లో.
ఏంద్రా 7 years
తెలుసా?
తెలుసు.
బొచ్చు వస్తుంది.
తక్కువ వస్తుంది, చాలా తక్కువ వస్తుంది.
అవుట్పుట్ ఇది పెట్టరా, ఇక ఇది పెడతాం ఇక్కడ ఇంకా ఎక్కువ వస్తుంది యాక్చువల్లీ. అవుట్పుట్ ఇది పెట్టు.
మనకు సరిపోయింది బొచ్చు చాలు.
సరే ఒక్క నిమిషం
ఆగదు.
మార్చా మన నోట్లో కొట్టే బేటే తెలుసా
ఏంటది?
4K కొత్రకా
ఓకే ఓకే. లిరిక్స్ బెటర్. కీప్ లిరిక్స్.
వీడు పాపం ఈ సాంగ్ పెట్టాడు ఉందని
నేను ఇంకోటి పెడతా. క్యూ
వైక్యూ సైలెంట్ లెక్క. ఒరే ఎంతో బాగుందిరా ఇది. చాలా మస్తు అయింది. ఇంత తక్కువ ఉందిరా.
అదే చాలా తక్కువ ఉంది.
దీన్ని అవుట్పుట్ పెట్టేకి వస్తుందా? నీ ల్యాప్టాప్ స్పీకర్స్ పనిచేస్తున్నాయా?
వస్తుంది, పనిచేస్తుంది.
ల్యాప్టాప్ అవుట్పుట్ పెట్టాం. ఇక్కడ ఉండదు, హెచ్డిఎంఐ పెట్టినాం కదా.
సెలెక్ట్ చేసి
డిస్ కంప్యూటర్ అనే ఉంది. నువ్వు ఆడియో అవుట్పుట్ సెట్టింగ్స్లోకి వెళ్ళి చేంజ్ చేయాలి. Yes. ఇక్కడ ప్లే చేయి.
Yo le iba a grabar, pero en baja calidad. Y ella me dijo que no está, es una maldita loca, una ratata. Ella lo que quiere es que la ponga en 4K, 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 4K.
అరే దీని సౌండ్ వస్తుంది, దాని రావట్లేదు. చాలు మీ స్పీకర్ చాలు.
Yo le quiero dar en 4K. 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 No, estoy cobrando por party más de 70K.
These all small booty stuff. If you know. తెలుసా? చూడలే బ్రాండ్ డే లో బ్లాక్ కూడా వాళ్ళ చెల్లి వస్తుంది ఆమంటది. ఆల్ దిస్ ఇస్ స్మాల్ బూటీ stuff, we do big booty stuff. ఆమంటది. ఇది ఉంటుంది. అంతా క్లియర్ దీంట్లో.
అదే
స్పీకర్ అవుట్పుట్ ఉంటుందా?
ఏదైనా చెప్తున్నా మైక్ వచ్చేటట్టుందా? లాగ్ ఇస్తారు రా, నీకోసం ఓపెన్ చేసి పెడతారు స్పీకర్ అవుట్పుట్. లాక్ ఇస్తారు రా, లాక్ ది మనకి వెళ్తాం.
ఆ పొక్కలో నీది పెట్టు, వస్తే పాటలు వస్తాయి. మరి actually I wanted to. So David. సుగున్ కెమెరా ఎందుకు ఆన్ ఉంది? దేంట్లో? ఆహా, ఉంచాలా ఆఫ్ చేయాలా?
అరే క్రేజీ
ఉందా?
చిన్న ప్లేస్ పెట్టుకొని ఏం చేస్తారు?
పెట్టు పర్వాలేదు. ఆడియో ఇంటర్ఫేస్ చేంజ్, అవుట్పుట్ ఇంటర్ఫేస్ చేంజ్, అవుట్పుట్ దీని బటన్ దీనికి ఆన్ ఆఫ్ బటన్ లేదా?
ఉంది కింద లాంగ్ ప్రెస్
హలో మాస్టర్ తిన్నారా?
తినలే తినాలి. అదే ట్రై చేస్తాను.
చేయడానికి కొంచెం తెలియదు, టైం పాస్ చేసుకొని వచ్చి పబ్లిక్ స్పీకింగ్ ఎవరో ఆడియో అవుట్పుట్ క్రేజీ వచ్చింది రాదు. ఇప్పుడు పెట్టు 4K, దాని బీట్ క్రేజీ ఉంటుంది. అది అయిపోయిన క్యూలో యాడ్ చేస్తాను.
Is it next in queue or in the queue?
Okay. Like, we can do one thing actually. Change na. Where's the this one?
దీని వీడియో సాంగ్ చూస్తున్నాను, తక్కువ ఉంటుంది తెలుసా? ఒకసారి ఒక్క మీద స్ట్రీమ్ ఆపేవా? అదే అక్కడ వస్తుంది సరే, లైట్లు వద్దులే, మళ్ళీ ఎప్పుడు చూద్దాం.
Welcome back after the lunch session, everybody.
సాంగ్ పెట్టానా నెక్స్ట్ కూడా ఒకటికి ఇది ఒకటి యాడ్ కానీ అదొకటి ప్లే కానీ చెప్తాను.
What do you want to discuss next? So, we looked at a part and we were having to discuss this data. Yeah.
I don't have an X. My only present is this.
Good one.
Hello. ఏంటో కదా
నువ్వే చెప్పాలి
ఏముంది
సెకండ్ సెషన్ తీసుకోవాలి నువ్వే కదా తిని ఏదో ఒకటి
తింటా రాట్లే
యాంటీగ్రావిటీ ఎలా ఉంది యాంటీగ్రావిటీ
పాత వర్షన్
ఓల్డ్ వర్షన్
కొత్తది బాగాలేదు అంతగా అయినా
కొత్తది మొత్తం
చండాలంగా ఉంది నా పాత వర్షన్లోనే ఉంది
ఇలా పెడతా నాకు అందరికి కొత్తది బాగానే ఉంది టూల్స్ బాగున్నాయి కదా ఏంటి 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 గోజిలా తెలుసా ఇక్కడ ఉంది సౌండ్ ఎక్కువ ఉందా తక్కువ ఉందా
తక్కువనే
ఉంది కదా లిరిక్స్ అయితే
ఇక్కడ కాగా ఇది కాగ్ మెటల్ మెటల్ ఇంటవా టూల్ మెటాలికా కార్న్ బ్లడీ వుడ్
ఫుల్ సౌండ్ పెట్టిపోతుంది అక్కడ ఇన్వెస్టింగ్ చేస్తున్నారు సెక్యూరిటీ గార్డ్
చాలా నేను తింటా ఈ ఆల్బమ్ చూసావా తెలియదు నువ్వు ఈ ఆల్బమ్ చూసావు ఐ You want to start a jump? It's basically Krishna Dashavadana. ఒక్కొక్క అవతారం మీద ఒక్కొక్క సాంగ్
Nice performance.
Stop competing.
But jam start is